Hi. This side better? Yes. Initially, this talk was meant to be about continuous delivery and Docker, but since DockerConf renamed its name, I've also renamed my talk. I think it's only fair. I already gave a talk in January at the Docker meetup. Some of you might have been there. And the reason why I'm not talking about continuous delivery now in Docker is because I still don't think it's a solved problem. There are many missing pieces. I'm getting closer to solving them in my own specific way, as all of us do, because we're very arrogant. However, I'm not there yet. Instead, I'm going to talk about using Docker in production, which I have been doing for about a year now. Most people are sensible, and they deploy Docker in development, and then in their CI, and then in staging. I just went straight for production, because I thought it was like really amazing, and I really like what I've seen. And it's been rock stable, rock solid ever since. I don't have a big production. It's just a couple of one-use, 4-core machines, 16 gig of RAM each. In terms of spec, they're very similar to what you get from EC2, the M3X Large, which some of you might be familiar with. But in real terms, a machine like this, even though it has the same spec, it's about 20 to 30%, between 20 and 30% more real power, because you don't pay the hypervisor penalty. Also, they're about 635% cheaper than the on-demand cost of the EC2 X Larges. But we all know that you go to AWS for convenience and for a choice, not for getting buck for pound. I also, for my staging, I'm also using a dedicated server. This is actually an in-house Supermicro, and this is the exact same server which I have, in my house. I know it's crazy, but I think everyone knows that by now. Everyone can tell that I really like hardware, and I will always choose a dedicated server, a proper bare metal server, over a VPS or EC2 instance or DigitalOcean Droplet or whatever the marketing people come up with these days, to make them sound cool. They're not. They're convenient, but not cool. The thing which really got me hooked on Docker, this was a year ago, is how fast it was. Like, I couldn't believe how quickly I could just write things, I just could dump things in a Docker file, run it, and it just worked. I said, no, this must be some kind of a mistake. It cannot work this well. So I took it into staging the next day, and it worked. I couldn't believe it, like 2 for 2. When did you try a new tool and it worked as advertised, out of the box, no problems, no quibbles? I haven't seen that in a long time. And then I said, right, the next day, the third day, I said, right, I'm going to take this in production. I have to see if this will actually work. And what do you know? It worked. I was so impressed. And ever since, I've been running into production. I haven't had a lot of problems. There were some problems I've solved, some problems I'm still yet to solve, but mostly it works really well. So, as all good and real Unix tools, it only solves one problem. And that problem is around the runtime for the process. Whether it's like a Docker image or a Docker container, it is the runtime, making sure that you have the same runtime, making sure that it works, regardless which hosts you run it on. And that's all nice and good. However, it leaves a lot of things for our bright and capable minds to solve, such as orchestration, such as firewalling, such as multi-host network configurations. And there are interesting tools which are now starting to fill the void, but 6 months ago and a year ago, you had to do it really dirty to get it working. And even then, it wouldn't work all the time. So, I already mentioned that, I'm arrogant. So, just to tick that box, it's Gerhard there. And I'm also very ambitious, so to tick the next box, it's the Gerhard Platform. And the Gerhard Platform makes use of Ansible and Docker to basically build a platform. I mean, everyone either works or owns a platform as a service, or is trying to with Docker, so why wouldn't I, right? And I'm not subtle like Linux and Linux. I'm the real deal, that's it. It's my platform, I'm calling it whatever I want, and that's it. So what does the Gerhard Platform do for me, and how do I make use of Ansible and Docker to make it work in production? For those of you that haven't heard about Ansible or don't know Ansible well enough, it's a bit like Chef, if you look at it superficially, but the more you start looking into it, you realize that it's more about orchestration than about configuration management. And that's a really cool thing, because all of a sudden, you can just like point it to host. It has no agents, so it just needs SSH. So by default, you just give it, you just point it to a server, and it can configure it from the very beginning. It doesn't have any Docker, it doesn't have anything, it just has SSH and Python. And all Ubuntu servers have that these days. And maybe other distros as well, but I'm not very familiar with them. And it just works. So I couldn't believe that, within like a couple of minutes from actually getting a new server, I can get it provisioned with Docker, with everything I need, with AUFS support, the whole deal, and it will just work. Also, more importantly, it does things as I would do them over SSH. So I can like shell into like machines and like do this, do that, and I can translate them into Ansible tasks, and it just works. So the feedback loops are very, very quick. And I like that. It also has a very declarative nature. Unlike Chef and Puppet, everything runs like nicely in order. There's like no jumping between things. It's like tasks one by one. If one task fails across one host, that host will be taken out of the play. And also, if, let's say, a task fails across all hosts, that's it. The run stops. It doesn't try to continue, and like it doesn't get itself into a mess, basically. And this is very useful when things go wrong, because they do go wrong. And when you mess up, you want like the world to stop. You don't want for it like to try and, like magically fix things. Also, I mentioned this, it has very thin abstractions because it only needs SSH, and it's not like the SSH which we use on the console. It's like beefed up SSH. It has some really cool things. It has some really cool tricks up its sleeves in that it reuses the same SSH connection for all the tasks across all the servers. It keeps them open. It does them in parallel. So it's very quick. It's not like having oh, I can build a shell script to do this. No, you can't. It's very difficult. But Ansible gives you very fast feedback. Also, it comes with all the modules which you would need. So for example, to talk to AWS, it has modules to do that, to provision EC2 instances, to configure load balancers, scaling groups, auto-scaling groups, security policies. It's all there. It's really, really good. Also DNS, like my DNS provider, I've been using DNS Made Easy for a long, long time, and it's just there. Like I could basically give my DNS Made Easy API key and API secret, and it just would work. I could like all of a sudden start modifying dynamically DNS entries. That was really cool. So I have this thing called P, which P is just a shim which wraps Ansible playbook. And it gives me some nice things, such as, for example, it integrates with my Mac keychain where I store a passphrase. That passphrase is used to decrypt secrets, like for variables, like API keys and stuff. So everything which I store, it's stored encrypted. And when I log in, my keychain, I store a passphrase which gets automatically retrieved, and it gets used to actually decrypt those secrets. That's part of Ansible Vault. It's built into Ansible. You don't have to do anything. You get it for free. It also does a couple of other neat tricks, but it's just basically a shim. It's just a wrapper around Ansible playbook. It's bash, nothing special. P is the only entry point. So with that, if I just run that on my shell, it will basically across all hosts, it will run all the tasks. It will set up Docker, the registry, all the services it will deploy, it will run all the tests, everything, configure my DNS, that across all the hosts. If I give it flags, I can say, right, I only want to run the Docker roles and the registry roles across all hosts. So let's say that I get a new host, a new server. I can just run that command. It will set it up with Docker, including AUFS support. It will reboot the host. It will do everything for me, and a registry. I always use Docker registry, private Docker registry on every single host, and it's really useful for that. That's an app. It's a Ruby app. I just run that command, and it will make sure that that app not only gets deployed across all the hosts, but that it also gets the hosts get configured with the correct Docker images, so that I can run the different processes which that app needs. It also resolves dependencies, so that app needs Elasticsearch. It will, again, start it up in a Docker container, make sure it's up and running. It can do that, by the way. It can check ports and can make sure that it's available. It's really good. Also, when I'm developing, it's really useful to focus on specific tasks to see, right, I just want to limit my run only to these 3 tasks and to see how they actually work. Also, I can only limit them to one host, Disco. That's actually my staging host because anything goes, just crazy stuff going on there. And it also has a verbose mode, and very, very verbose mode. It's exactly the same as the SSH client, where you can get a lot of information about what Ansible does behind the scenes. For debugging, it's very useful. Some of you might be wondering why haven't I used GP, which is like the abbreviation from Gerhard Platform. I had GP reserved for Git push for about 6 or 7 years now, since I started using Git. And it's just in the muscle memory, so I just don't think about it, so I just couldn't use GP. However, I alias all the things which I use, like for example, Docker is D. D is my Docker, V is my Vim, T is my TIG, and so on and so forth. G is my Git. So remember this next command, this alias actually, and just think about it as Docker run is my doctor. That's how I think about it. So Docker run is my doctor. The platform itself, obviously, it's a bit of a joke. I mean, it's only for me, but it's like a nice way to think about it. That I'm building a bit more than just like a tool which only I will use. So the platform itself isn't important, but the things which I have learned along the way definitely are in building it. The first thing which very early on I had to solve is how to manage the Docker images. And while you can use the hub, the Docker hub, and it's great, very soon, and if you have been using it long enough, you'll start seeing problems with it. For example, images which don't download completely, the Docker daemon hangs, the images get corrupt. It happened to me once for MySQL, so I have seen that happen. So I'm just using a private registry. There is a Docker image for that. There's a Docker image for pretty much everything these days. Not all of them are very good, but this one is. And it's S3 backed. So every single host gets to run a Docker registry, and that Docker registry is connected to an S3 bucket. So when I build and push an image on one host, all of a sudden becomes available across all hosts. So when it comes to, for example, running Nginx, I can say localhost 5000, start the Nginx process, and that will pull it from my S3 registry. Service dependencies. Now, service dependencies are an interesting thing, and I've seen many, crazy solutions, some good ones. But I can just tap into Ansible's declarative nature. I can say, start MySQL first. If you don't have a MySQL image, pull it down, start it, or actually build it in my case, because I'm not using the public ones. I always use private images. So build it, push it, start it, run it. Make sure that it's running before you move on. That's very, very helpful, because you can get some really tricky situations. It's, for example, your app expects MySQL to be there, but MySQL hasn't started yet, or it has started, but actually the process hasn't started, and it's not actually listening for TCP connections. So Ansible just solves it for me. I'm also moving away from that because it's nice and it worked fairly well, but I'm leveraging runit. For those of you which maybe haven't heard about runit, it's a supervisor. It's one of the best supervisors I've seen and known. I mean, that includes systemd and whatever else is out there. Supervisor D, for example. There's another supervisor called Supervisor D, which I know is confusing. It's a good one, but nowhere near as good as runit. And you can declare dependencies for a service. You can say, right, this service, start these containers before you start yourself. So it's very easy to declare dependencies like that. Service dependencies. When it comes to container supervision, when the Docker run restart flag came out, I jumped onto it like within 5 minutes. So when I found out about it, right, I said all my playbooks, all my Ansible playbooks, I'm going to convert them to use the restart flag. And within 5 minutes, I had it deployed across all my hosts. There are not that many, but still. And I didn't have a problem with it. However, it fits very nicely with the previous thing which I was mentioning about service dependencies. Again, run SV, it can supervise Docker containers really well. Also, I would get for free svlogd, which can do log management for Docker processes, Docker containers, and it can send them to like a syslog aggregator, or like a syslog aggregator as a service. For log management, I have a volume, which is mount log. So for Nginx, for the Nginx process, for example, I mount the mount log Nginx inside the container. I use locally syslog ng, which then I forward the logs to a syslog aggregator as a service. But svlogd can solve some of the problems, not for Nginx, because Nginx doesn't log to standard out, but for others. when it comes to raw network I/O, there's this flag, which again, it was mentioned today, net host. So my Nginx container, I have a single Nginx process, which obviously spawns its workers. But I just use net host, and then I don't have to do any port forwarding, any trickery. It just works. It just binds to, it just uses the host network, and I get like the best network I/O I can. Also, when it comes to the raw disk I/O, I mean, this is common knowledge, just like mount to volume. But the one thing which you can do and go further than that, you can make that volume an LVM. It can be like an LVM, and you can get snapshots for free. Now, Cluster HQ, is anyone from Cluster HQ here? Cluster HQ is one to watch. I'm really looking forward to what you're going to do with it, because ZFS, I mean, that's my favorite file system, and I've been aching to get it on Linux for a long time. I think it's just about getting there, so I'm looking forward to what you have in store. When it comes to service discovery, can anyone tell me what runs on port 22? Right, 3306, 80, 443, right. So we have been associating ports to services all these years. So if you don't have a lot of services, it's a model that can still work. For me, I have only about 40 services and it still works fine. So when it comes, for example, to like my Ruby process, I just bind it to port 660,000, and it just works. I mean, honestly, when it comes to service discovery, new tools are coming out. Weave, I'm really interested to see the implementation of Weave, and Rudder as well. But some simple things still work, unless you have like huge, massive deployments. It's worth checking it out. It's not a bad solution, actually. If you don't have, you know, like hundreds and hundreds of services. How many of you know about SO reuse port? Right, okay. So that came in, was a patch submitted in the 3.9 kernel, and it came out in 3.9, which basically allows you to bind multiple services to the same TCP and UDP socket. And I think this was submitted by someone from Google, Tom Herbert, if I remember correctly. And they have seen that the threads, between the threads which have the most connections and the ones which have the least connections, there's like a threefold difference between how efficient they are. So it'd be very interesting to see what happens when all of a sudden we can have one single port for like one service, and we can bind multiple containers on the same port. It'd be really interesting to see what happens then. Hopefully someone will take the time to submit a patch for it. When it comes to firewalling, I'm sure that most of you might already know this, but you expect the MySQL when you say bind to localhost in this port that it will do so. Well, when you start it in a Docker container and when you publish the port, all of a sudden that becomes public. IP tables would be the best solution. Firm also is really interesting to check it out when it comes to working with IP tables. You still have to be very mindful of Docker because you're sharing the same IP tables, chains, and rules. So some interesting things, you know, it's an interesting problem. But the simplest solution and the most pragmatic solution, just when you publish a port, just by default, just stick 127, just stick localhost in front of it. Again, it works really well. When it comes to config templating, as much as I love Bash, I think there are like better solutions out there. And a lot of people, I mean, most of you have proved that it can be done, and your set skills are really impressive. So are mine, by the way, but we're not bragging now. But the point is that you don't have to use that. You can use, for example, ERB or Jinja or Go template, and it works really well, and it's much better than actually Bash templating. Also, you can mount the config. This was already mentioned, but rather than just mounting a single file, you can mount the whole directory. When it comes to changing the config, so my Ansible templates and manages the config. When it comes to basically reloading the config, like signaling Nginx to, hey, there's a new config I dropped for you, please like read it. The signals work really well. So like Unix signals, it's just like you can still see the processes even on the host. You can see all the processes. Just send them a signal. Nginx will do the right thing. App runtimes. Now I know this will be very controversial because this whole like Docker mantra of like build once and run everywhere. However, we have seen this problem with database containers where you need to basically the data, you store it outside of the container, you have a volume which you mount inside. Initially, I really like the approach of like having my app code inside the Docker image and just distributing it like that. But then I realized, like through experience, that if I run it from a volume, I get much better I/O. I can do snapshotting because of LVM, and most importantly, once the process starts, once the processes start and they load all their data, if the volume changes state, it's fine because the code is already in memory, right? So if you want to like restart them at that state, just revert the snapshot to the version which you needed and just start new containers. It works surprisingly well. So all my Docker images for apps are just runtimes. When it comes to monitoring New Relic, which by the way is free for hosts, I just run the agent in a privileged container. It just solves the problem really well, alerting as well. Linode Longview also was a really useful one to have, also in the privileged container. When it comes to sysadmin tools, again, just install them, all of them in a container, run it in privileged modes, and all of a sudden you have them available and you don't pollute the base host, and it's really nice to keeping things nice and clean. It's very important for production. So, how fast is the Gerhard platform? There are like a lot of things which are happening. I'm hosting PHP apps, some really legacy ones. They've been in production for maybe 10 years now. Ruby apps, a bunch of Ruby apps, C processes with high I/O, and then the usual suspects, Percona, Elasticsearch, and Redis. It's very fast. In terms of numbers, it takes me 5 minutes to provision a base Ubuntu 14.04 operating system. This includes Docker, AUFS support. I always use AUFS, by the way. It's been the storage backend which Docker has been using the longest. It's the one which has been used in production the longest. And even though Device Mapper is interesting, and not only because it's based on LVM2, but because it comes from Red Hat, but it's AUFS support, I had less issues with it in production than with Device Mapper. A call production setup, so once I have Docker set up and the registry, it takes 10 minutes. In 10 minutes, I'll pull all the app dependencies, all the apps, run all the tests for the apps which have tests, mostly Ruby apps, and everything, publish containers, publish images if I have new images built, it takes 10 minutes. When everything is already set up and everything is cached and I have all the images, it takes 2.5 minutes to do like a whole rerun from end to end across all hosts, which I think is pretty good. When it comes to recreating all of production, let's say that I lose a host, in 15 minutes I can have everything back. So just think what that means, to have your production back up in 15 minutes, I think that's pretty impressive. And S3, it's part of the reason why it's so good and so quick, and I can depend on it. Also raw hardware, it makes a big difference. So, thank you Docker for enabling me to build my own platform, and for making me think that I can build a platform. Again, it's just a joke, it's not real, but it is running in production and it works really well. And thank you Ansible for the very thin abstractions, the quick feedback loops, and enabling me to do the same thing in production just as I do it in development. And one last point which I want to make, and this is very important, is that there is no such thing as perfect software. It's only the software which you don't know well enough, and you think it's perfect. But as you start like getting into the meaty parts, you realize that there are like a lot of things which are lacking. And open source, it's a good way of like having more people help with those lacking things. But overall, as you start getting into different like Docker or Ansible, the deeper you dig in, the more you realize of all the imperfections and things which aren't just right. And you either say, right, this is crap, and then you move on to something else, whatever that something else is, or you just get to love it and accept it. And it's a bit like my wife, but don't. Right, you get the point. So yeah, thank you very much. Questions?
Next.
So hot in here. Oh man.
Okay, it's me again. So, how many hosts do you have? I mean, any figures are only makes sense.
3 servers, 4 cores each, real cores, 16 gig of RAM each, plus 1 for staging.
Okay, and like how many like CPU load, for example?
CPU load between 30 and 50%.
Like all the time, or like steady,
well,
or
this
peak
is like
time?
Peak time between 30 and 50.
Okay.
In terms of I/O, I mean, again, when you have raw hardware, you don't like see that much load. So, for example, in terms of I/O, it's pushing about maybe 10 terabytes a month.
What was the biggest challenge? I mean, when you have 12 months production, I quote now, like, what was the biggest challenge? I mean, it was very raw Docker 1 year ago, so.
Okay, the biggest challenge was not trying to be sucked in by all the noise that's happening in the Docker ecosystem. There are so many solutions coming out there, so many good solutions, and trying not to pay too much attention to those and just basically trying to see what is worth using and what isn't, and trying to see what's also the best way, but also the easiest way of getting things done. Because you can be trying new things out, and you can be like moving from one thing to another thing, and not learning anyone well enough to actually be able to deploy it and to be able to trust your production with. So I think that's been the biggest challenge.
Next question.
Okay, thank you.